The curve C has equation y equals a half x cubed minus 9x to the power 3 over 2 plus 8 over x plus 30 for x greater than 0. Find dy dx. Show that the point P for minus 8 lies on C. Find an equation of the normal to C at the point P, giving your answer in the form ax plus by plus c equals 0, where a, b and c are integers. So let's have a look at this then. So part A, first of all, y is equal to, well, it's x cubed over 2, so let's write it like this, minus 9x to the 3 over 2, plus 8x, bring the x up from power 1 is what that is, so that's minus 1, plus 30. So that tells us then differentiating y dashed, or dy dx, let's write dy dx. So differentiating, run along the row, differentiate term by term, 3x squared over 2 minus, the 3 over 2 comes down to be with the 9, so it's 27 over 2, isn't it? X to the 1 less than 3 over 2, which is a half. Then the minus 1 comes to be with the 8 to make minus 8, x to the 1 less than minus 1 is minus 2, and the constant goes to 0. So dy dx equals this. Show that the point P lies on C. So let's have a look at B. So P, which is the point 4 minus 8, gives. So let's put these values in. Put the x value in for here. Y equals, so put 4 in. 4 cubed over 2 minus 9 times 4 to the power 3 over 2 plus 8, and I'm going to put over the x now, and x is 4 plus 30. So let's work out what that value is. So equals 4 cubed is 64 over 2 is 32. 4 to the power half is 2, and 2 cubed is 8. So minus 9 eighths is 72 plus 8 over 4 is 2 plus 30. So we've got 30 and 32 is 62. 64 minus 72 is minus 8. So P is on C. So P is on the equation, the curve C. So that's part B. Find the equation of the normal to C at P in this form. So here's our dy dx. So part C now. When x equals 4, dy dx, what does that equal? Let's work it out then. 3 over 2 times 4 squared minus 27 over 2 times 4 to the half minus 8 over x squared, isn't it? And that's 4 squared. So let's work this out then and get the gradient of the tangent, dy dx. 16 over 2 is 8, and 3 eighths are 24. This is a 2, 4 to the half is 2, the 2's cancelled to leave minus 27. And then we've got 8 over 16, which is minus 8 is 1 over 2. So we end up with 24 minus 27.5, which is minus 3.5, which equals minus 7 over 2. That's the gradient of the tangent. We want the gradient of the normal, don't we? So the normal will have gradient. So the normal to C at P. So normal at P has gradient. Well, if the gradient of the tangent is that, the gradient of the normal will be 2/7, won't it? Because this times this will give a product of minus 1. So that implies the normal y minus at P, the point P, the y value is 8, so it's y plus 8, is equal to the gradient, 2/7, x minus the value here, 4, because it goes through this point P, doesn't it? So that tells us that. Now let's turn our attention to this part of the problem then. So that implies, move the 7 up, 7y plus 8 is equal to 2x minus 4. So all I've done is move the 7 up from divided times. Expand the bracket, 7y plus 7 eighths of 56. Expand that bracket, expand this one, 2x, 2 fours are 8 with a minus, so it's minus 8. So 2x, I'm reading it from right to left. 2x is as is, leave it there. Move the 7y to minus 7y. Then move the 56 over to be with the minus 8 to make minus 64. There's nothing left on this side, and I've written it down from right to left. So here we have the equation of the normal. And the question, let's just look back at the question above. A, B, and C are integers, so there's no common numbers here. So A equals 2, B equals minus 7, and C equals minus 64, all integers.